شكرا جزيلا على المحافظة على الوقت. Our next speaker دكتور محاد بعوين. تفضل. He is going to talk about reusing treated wastewater in Muscat social survey. وهذا joint research. دكتور محاد he has a BSc from Sultan Qaboos University, MSc Imperial College UK, and PhD from University of Alberta, Canada. Research interests include water and wastewater treatment and management. Please, 15 minutes.
Thank you. Assalamu alaikum. I'm very glad to be here, and thanks for this chance to present some of our results in one of the major research projects with the major wastewater company in Oman, Haya Water. I have chosen the social survey part of the project. It has different elements, but today I thought that I should focus on this part because it's not been well studied in our region. I want to acknowledge also my co-workers, the research assistants, Halat Tureki and Amal Sabti, for helping in conducting this study. The outline of this presentation is going to have some general introduction about the wastewater in Oman, and then a background of the treated effluent reuse there, the objectives of this specific study, and the current treated effluents applications in the study area, and also some of the future perspectives where we see the treated effluents to be used in the Sultanate there. And at the beginning, we'll start with Muscat and surrounding areas. And then I will go directly to the social survey results and throw some conclusion at the end. In Oman, generally there are, you can see like any other countries in the region and also in the world, you have, according to the availability, you have different types of treatment. It varies from no treatment, like you leave it to the biological treatment by having certain landfills and you put it there. And it goes to primary, secondary, and tertiary, which is well-planned treatment, and we have these in different places. I'm just giving those major cities as examples. Then the disposal of that treated effluents or the final effluents from those places varies also. We have different applications. Some of them are specific for Oman. Maybe the others are using it in the region, but there are also international applications for this. We have, of course, the widest spread or the widest application is the landscape irrigation, which is also, we have a special one, which is injection the treated effluents to the groundwater. And maybe that will also happen more as we have long coasts in Oman, and maybe we need to fight the salinity, and that can be one option for doing that. There are also, of course, some industrial applications for cooling and processing. The wastewater has also another side. After you treat the water, you have also a sludge, which is the solid remaining there. And generally in Oman currently, most of the plants, they just take that sludge or the watered sludge to landfills, while now in Haya, they are doing a composting plant and they are actually selling this sludge as fertilizer. At the beginning, they had some troubles in selling it, but later on, some farmers, they start to appreciate the sizes of some vegetables, and they start to get encouraged about using it. Also in Salala, I think they're building a thermal plant to again try to make use of this sludge. This is a typical layout. I'm not sure if, well, yeah. It's typically, this is the tertiary treatment plant layout that is used in Oman, which starts from primary holding tank, and then the biological treatment, and then the filters and the chlorination, and then the water is ready for reuse applications. And also at the bottom you have the wasted sludge. In large plants, they are now planning to have the treatment of the sludge. Although in Muscat they're having a central treatment plant. Instead of having it in each plant, they are taking everything to a composting plant. So there is also a transportation issue with it. The treated effluent reuse nowadays, with the huge developments in major cities, growth in population, of course, the advanced technologies, and also the new need for safer water, better utilization of this, all these demanding more water. Again, this is putting our natural resources under huge stress. In Oman, the authorities are actually anticipating that there are tremendous amounts of treated effluents will be produced. Again, this might be a good thing, or it can be also a bad thing in terms of huge amounts of water that you need to handle and dispose, or you can make use of it. So we need to find some best options for disposing and reusing such a large volume of water. And the issue is maybe one solution is not always possible. You need multiple thinking. One of our speakers, I think the keynote speaker at the morning here, he mentioned some drivers. I don't think I need to go through them, but again, one of the issues is the lack of the adequate local supply for the water, and this is a major issue. If you have this water to replace the need for that water, then why not using it if it's meeting our standard? And the other, then you have, if you do that, you will conserve the natural water. You can make use of it in a better way, and other applications as well. However, there are also regulations that we have to meet, and these are in sometimes obstacles. You need to have an integrated system to apply and go through them. So the objective of this is to present the current status of the treatment system in Oman and the reuse applications, what we are having right now. And then we can move forward to see the options that we can see. We have, for higher water, we suggested 6 options. We will study them for the company. Of course, we're doing field sampling. We're doing also modeling for them. But part of it was doing the social survey to see the acceptance of people to such options. And the options are actually urban reuse for different application, industrial reuse because we have industrial areas around in Muscat, agricultural reuse, if we can do some of this in Muscat or in the vicinity of Muscat, we can do that. Groundwater recharge, we'll see that. And we also thought that we should go a little bit beyond that to see, can we also generate some power of this? Can we actually use it for potable reuses, either indirect or direct? And again, then the issues come there. This is just a summary of some plants over Oman. Of course, we have more than 400 wastewater treatment plants in the country. I'm just choosing some big ones and some examples of industrial one. As you can see, most of the application is landscape irrigation. We have recharging groundwater in one of the places. The sludge is also, we have a high amount of sludge per plant. So if we can make use of that one, it can serve several purposes in reality. The future application, I believe personally that we cannot use only one solution. I think we should also try to mix the solutions to meet the variable demand all over the year. Because if you choose agriculture, there is only demand in certain seasons, and then you will have excess water, so you have to have solution for the excess water at that time. And also you have to see different customers in order to promote the use of this treated effluents, also psychologically and socially among people, so that everybody is appreciating this water as a water resource rather than a wastewater. Again, I think the word treated wastewater should be changed. It should be treated effluents, or it can be reused effluents, so that we try to hide this psychological barrier. But we need also to do a good job in terms of treating the water. Yes, I think I can do it. Social survey, we actually conducted a survey over Muscat area, and we have distributed it among the regions there. We decided to go for around 100 to 120 houses from Qurum, Ansab, Matrah, Sib, and all those areas. And we're knocking doors, and students were doing it in the field. These are some just biographic data about it, how the percentage of male and female that we could meet, although we have the same number of male students and female students to knock the doors. But again, the majority of people responding were male compared to the female. Some data about the ages. Majorities were in the age from 20 to 30 years that we met. 30% were engineers and 30% were employees. So there are some kind of educational background. Again, the number of kids in the house, because if they want to reuse this, they would care more if they have kids. So we want to see the acceptance also on the social life as well. We asked them about their knowledge about wastewater treatment, just the term wastewater treatment. We found that, surprisingly, that almost 30%, they don't know anything about wastewater. Okay? So they don't even hear about the word wastewater treatment. Some people, they say, we know a little bit, but we don't really know about it. And 30%, they said, we are well informed about it, and we know where it's being used. Then we asked them about general terms in treatment of water and wastewater. For example, do you know what is potable water, what is wastewater, what is gray water, what is sewage recycled water, what is treated effluents? And again, the results were variables. For example, when you come up with new terminology like gray water, half of the people or the surveyed people, they don't know anything about it. And also treated effluents, third of the surveyed people, they didn't know anything about it. Then their perspective of those responding to the individual impact on policy making. We asked them, do you think you can make a change? Like, does your opinion matter? And about 40% of them, they said, I don't think that it will matter. So that's why I don't need even to worry about it. And again, there is a room for public awareness. And I think it's the opposite. Actually, if you talk, and you can send your message, there are always people who will listen to you. Only 25% or 26%, they think they have some strong impact on changing these policies. We asked them, do you know that there are Omani's regulations for water and wastewater? And more than 57%, they don't know that these exist. Okay? And I believe these are, if you go to the normal people, and that's where the awareness is actually missing. And then when choosing an appropriate reuse, now we started to asking them about the reuse application. Would you support them or not? And we asked them to rank them in terms of if the reuse will prevent pollution of the sea or the groundwater. Would you support that? Most of them, they said, yes, we will support it. If it will protect the human health, yes, we will support that. So again, everything is positive when you're reusing it. Once they know that there are benefits coming from this application. Then we ask them to rank the reuse applications, like irrigating golf courses, landscape areas, public parks, groundwater recharge, and all those. And again, the majority of people, they are with these options. They have no problem with it as long as it protects the public health and has all these benefits. We asked them specifically about this company. Do you trust the wastewater treatment companies? And few amount of people, they say we don't trust. Most of them, they have limited trust because they think that there is more need to work in terms of these sensitive issues. Then we asked them, how do you think you can communicate well with these authorities through the different media levels, from articles to emails or mails or presentations? And some of them, they prefer the things that they can read or see, like newspapers and TVs. So if you can show these ones, they don't want you to come directly to their houses, but if you can improve these on these public media, they would be interested to have this. So to the conclusion, currently the treated effluent resulted from major cities in Oman are used in mainly landscape irrigation. However, we need to change this because of the increase of the huge amounts of treated effluents. More than 30% of respondents have no knowledge about wastewater, so we need to do more in terms of awareness and educating them. Public have no general understanding about differences between water and wastewater terminology. So they are confused whether this is water or wastewater treatment. So this is one of the issues. Again, the awareness is needed. More efforts are needed to recognize users' needs and communities' goals for health, safety, and ecological concerns and costs. So you need to go to them in order to convince them, and they will support, definitely. There is a knowledge gap that might affect the public perspective about wastewater and treatment and reuse. So if you don't close this gap, there will always a problem in terms of going forward without their support. Respondents are very positive to support the potential reuses, because once they know that these are for the general benefit of the society and the environment and the nature, they are with it. The public might be reluctant to accept any kind of reuse that is directly or indirectly related to food and drinking. If you say, do you think that we can treat it and bring it to the water supply? Most of them, they say no. While they would accept it can go to the groundwater, and then the groundwater will be treated. Finally, I would like to acknowledge the support from Higher Water for this, the ministries, the regional municipality and water resources, and the environment and climate affairs for all the service and support that they have given us for getting any data. Salala, sanitary drainage service, also they were very keen in giving us information about the groundwater issues there. And of course, our technical staff and postgraduate students who are always there to support. Thank you very much.
Thank you very much. Thank you, Dr. Mahad, and we really trust all the waste treatment company. Our 6 speakers will talk about somatic DNA and male-specific RNA, chirographic and as available indicators for the rules of wastewater's influence. When we talk about health and risk assessment, definitely we need to go to the expert peoples. And our speakers today, Dr. Saleh Al-Migran, board expert in the wide range of Environmental Engineering Association, advisor of environmental and health risk assessment. We wish you all the good luck in your presentation, and I will be very sharp with you regarding the time. 15 minutes, please. Thank you.
Assalamu alaikum wa rahmatullahi wa barakatuh. This work is in English, so we will allow me to speak in English language. As you know, the presentation is about design for new microbial indicator system for reuse of wastewater effluents and irrigation. We are going to run through significance of microbiological assays, bacterial indicator organisms, ideal indicator organism, viral indicators, bacteriophage and coliphage, methods and material results, and we will run into a conclusion. The significance of microbiological assays, as you know, is very clear. So, because many reasons. As you know, many pathogens are continuously present in wastewater. Also, these pathogens may survive conventional treatment, may pass tertiary filtration. Some are resistant to disinfection, for example, spore-forming bacteria. Just to review, the diseases associated with treated wastewater can be classified into bacterial, for example, cholera, viruses, for example, polio, hepatitis, which is an endemic in our country or in the region. And the third class is the parasites, which are the helminth, which is designated as high risk, high incident. To summarize this, as bacteria, diseases may be associated with water and wastewater, include typhoid, shigellosis, salmonellosis, viral rotavirus, polio, hepatitis. Again, the parasites, for example, Giardia, Cryptosporidium, helminths, and so on. So, the detection is very important. It's a shield against the loss which will be caused by these diseases. We have the direct methods and we have the indirect methods. Direct methods include the PCR, immunoassay, but these methods are very expensive and need very skilled persons. The indirect method is using the so-called indicator organisms. The ideal indicator should have several features. Present whenever pathogens are present, more resistant than the pathogen itself. It should correlate with the amount of pollution, easily detected, harmless. That means we can, in the laboratory, there will be no outbreaks or danger of this organism. Constant characteristics, absent from unpolluted water. The ideal bacterial, as you know, which is used are fecal coliform, fecal streptococci, Clostridium perfringens, but several studies showed no association with viral presence or parasites, which are more resistant than bacterial indicators. So what we can do, we have to care for the viruses, because viruses are different than bacterial itself. Viruses are acellular, they are protein, smaller than bacteria. Even some viruses infect bacteria itself, much resistant and could be dormant and latent than bacteria. Also, the viruses tend to absorb to very minute particles, nanoparticles. What we've done is we have studied the resistance of 5 microbial indicators of environmental stresses using sand filter and UVR. Correlation were also studied. The 5 selected organisms were fecal coliform, which are usually used widely in water and wastewater indicator, fecal streptococci, Clostridium perfringens, which is anaerobic bacteria, DNA coliphage, and RNA coliphage. Our results showed that the number of the 5 indicator organisms in wastewater, fecal coliform, followed by fecal streptococci, then DNA coliphage, then RNA coliphage, followed by the Clostridium bacteria, for both influent and effluent. The reduction in percent of the 5 indicators studied is shown in this table, which shows that the DNA and RNA are more resistant than fecal coliform and fecal streptococci. Again, the resistance to sand filter decreased in the order of Clostridia, more than RNA, more than DNA phage, more than fecal coliform, which are widely used, and the least was the fecal streptococci. But to the UVR, the order was Clostridium perfringens was the highest, followed by RNA, followed by DNA, followed by fecal coliform, and the least was fecal streptococci. We studied the inactivation rate constant K in meter square per joule, which is showed that the Clostridia, or the anaerobic bacteria, was the highest resistant, followed by fecal coliform, fecal coliform, then fecal streptococci, DNA coliphage, RNA phage was 0.002. As you know, the K value, the least the K value, the highest the resistant, which is according to Chick's law and Watson law. The conclusions shows that the study suggests the use of RNA colophage as a primary indicator. The investigation proposed the limit of this phage as 20 PFU, plaque forming unit, per 100 ml, and 50 PFU per 100 ml as a new guideline for unrestricted and restricted reuse, respectively. The test is simple, safe, and inexpensive, and can be obtained in less than 18 hours. These two indicators, if used in conjunction with turbidity, I think it is a very sufficient indicator system which can be obtained in a few hours. Thank you very much.
Thank you, Dr. Saleh Al-Magrin, on keeping the time. And now we'll go to the last speaker.